Hi everyone, today we are going to discuss about motion in a straight line chapter. This is the part 1 we are going to discuss about. I am starting from basics, listen carefully. First we are going to discuss about what is the particle. What is the particle and what is the body? And what is the difference between these two? What is the particle and what is the body? Suppose you are taking an atom and you are taking this marker. What do you say? Atom is the particle and this marker is the body. This marker we are taking and earth is there. Which is the body and which is the particle? This marker is the particle and earth is the body. So when we are observing these definitions, how can we give the difference between the particle and body? So particle means the body which is having the negligible dimension. The body which is having the negligible dimension, that is called the particle. So the body which is not having the negligible dimension, that is called the body. When we are going the comparison of atom and marker, atom is the particle and this marker is the body. Same marker we are treating as a particle when comparing with the earth. Why? This dimension is negligible comparing with the earth. Now we are going to discuss about what is rest and what is motion. What is rest and what is motion? So generally what we are saying, suppose we are sitting in classroom. All students are at rest condition and the teacher is moving from one place to the another place and teaching that lesson. We can say the teacher is in motion. But according to physics, how can you say the difference between rest and motion? Rest means the position of the body does not change with respect to time and surroundings also. Suppose I am starting the class at 9 o'clock. The class is going on till 9:30. Till 9:30 students are at rest condition and I am in moving condition. So the position of the body does not change with respect to time. You can say that is the body is at rest condition. Like that, what is the motion? The position of the body does changes with respect to time. You can say the body is in motion. So generally we can say the rest and motion, we can give general definitions of this one. But here we are using one point, that is rest and motion are relative to each other. Relative to each other. Why we are using this statement? Just now I have given one example. Class teacher and students. Students are at rest condition and class teacher is in moving condition. But when we are taking the earth is the reference frame, student is also moving and teacher is also moving. So with respect to earth, both are in moving condition. But with respect to time, what we are saying, students are at rest condition and teacher is in moving condition. So from this what we are understanding, we can't say permanently the body is at rest or the body is in motion. Immediately we should raise one question, what is that? With respect to what? So we must take the reference frame. With the help of the reference frame and with respect to reference frame only we can say the body is at rest or the body is in motion. So students, now onwards don't say the body is at rest, the body is in motion. Simply we should raise the question with respect to what. Okay, that's why what do you say? Rest and motion are relative to each other. Then we are going to discuss about one side I am taking the distance, another side I am taking the displacement. One side I am taking the distance, another side I am taking the displacement. Generally in our daily life, still many people are confusing what is the difference between distance and displacement. Some people are thinking both are same only like that. So sometimes we are taking both are same only. What is that condition? First of all, we have to learn about what is the distance and what is the displacement. What is the distance, boys? Suppose you are running on the road. You want to meet your friends, friend A, friend B, friend C, friend D. Finally you are reached to the home. How much distance you are covering? Suppose you are covering the 300 meters. See, look here. You have started at A and reach to the B. Then going to the C. Then reach to the D. Finally, you reach to the E also. So total distance is 400 meters. Simply we can use total path length covered by the body. Total path length covered by the body is called what? Distance. So you have started your journey at A to B, B to C, C to D and D to E. Total path length is nothing but distance. And one more example we can take it in our daily life. Our speedometer is representing along with speed distance also. How many kilometers that bike is covered? 20,000, 10,000, 9,000, depends on that how the person is covered the distance, we can give that. So in that, simply it is giving the distance traveled by the bike. Daily we are going to college and coming back to home. You are going to college and coming back to home. So total distance traveled by the bike, speedometer is representing in that how many kilometers. So whenever the people are raising that what is the distance means, I think now we can say that total path length covered by the body is called the distance. The next thing is the displacement. What is the displacement? Shortest path from initial to final position. From initial to final position is called what? Displacement. So this is the distance and this is the displacement. But what is the difference between distance and displacement? See, now you are started at A, reach to the B, then reach to the C, then reach to the D, then reach to the E. From A to E, already you know the distance, 400 meters. From E to A, the distance is 10 meters. Already you know that distance is 400 meters. But what is the shortcut? What is the shortcut? We can say from initial to final position is nothing but displacement. This is the displacement. And one more difference is also it's there. Here we didn't mention any direction. Total path length covered by the body is called the distance. But in this case what we are mentioning, that path length from initial position to final position. So clearly it is having the direction. But in this case there is no direction. So we can mention here it is a scalar quantity. It is a scalar quantity. Then it has both magnitude and direction. You can say it is a vector quantity. It is a vector quantity. Then what is the unit? How to measure this one? Both the things we should measure in meters. We should measure in meters. And here also what is the unit? Unit is the meters. This is also unit is the meters. Here dimensional formula is L and here dimensional formula is L. Thank you everyone.